So we're back in the game animation sample project. I'm going to show you how to set up different idle animations. So here's our katana, here's our spear. Twin sword is the same as our spear at the minute. Here's our magic, here's our pistol, and here's our rifle as well. So I'm going to show you how to set all that up. If I go back to my katana, I'm going to also show you how to do its own poses, including its running animations. So I do have to do credit where credit's due. I have to give credit to Wanli, who I will link a description in their video on it, showcasing what they'd set up, and I followed the breadcrumbs, and this is what I came up with. Gotta give credit to Clydies, again, started the breadcrumb and got the ball rolling so that we could make our full locomotion system for this. First, a quick word from our sponsors.
Subscribe to my dad.
So to get this set up, we're just going to come to our content drawer. I'm going to search for an enum that is called stance. And then we'll find it, and it should only have stand and crouch. So we're just going to add a bunch. So I've got prone, I've got katana, spear, magic, and pistol, and then last one we've got rifle, like that. And then we're going to open up our animation blueprint. So inside us, our AVP sandbox character is just there. We're going to open that up. We're going to come to the logic, and we're going to update states just there. And then at the bottom, we've got the crouch state checking this here. So we're just going to grab this and duplicate it. We're going to open up the sandbox character stance or state and make sure it's not there. And then we're going to add the variable for it if it's not there. And all that needs to be your enumerator. So E state or E stance. E stance, like that. And then we compile that and save it. Go back to the AVP, and then the variable that is being set here, we want, so this stance, and we're going to set that here. And then we need to find it off. So remove the binding, go back to it and get the sandbox character. Then we want to find the stance just here and just plug that in just there. Now this will break your crouching, so we just need to fix that quickly. So if we go back into sandbox character where it's crouching, we're going to get our stance. We're going to uncrouch and set it to stand, and duplicate that and set it to crouch when it crouches. So this will fix the problem of your crouching just here. I'm going to get a input, so I'm just going to use the 1 and get stance, get a switch. Then going to set stance. So on stand, if we're standing, I want to put it into the katana stance, and I'm just going to move between all my stances. So when I'm in katana, I just want to move into spear, and when I'm in spear, I want to move into magic, and when I'm in magic, I want to move into pistol, and when I'm in pistol, I want to move into rifle. And then finally, when I'm in rifle, I want to go back to the stand state to be able to move between all of my states. I'm just going to put a print string on the end here so that we know which state we're in. And connect all of these nodes up to the print string. Now you should have a way more dynamic way of setting this up, for sure. This is just an example. So now you can see that I'm moving between the states. and my crouch works as well. So now for the meat and potatoes of the video, setting up the post search databases and making sure that our animations run and move through them. So we're going to go to the characters, UEFN, animations, motion matching data, post search database dense. And the first one that we're going to do is the idle. As you can see here, I have been testing and playing with all sorts to try and get you guys the most accurate way of doing this. So we're going to go to our idle and we're going to come over to this side. I'm going to add a column, and this one is going to be an enum or column, and we're going to tie that to stance, like so. And what this enum or column allows us to do is, if we are in standing or prone or katana or spear or whatever, we can choose multiples of these stances, and it will go into this post search database. So this post search database is checking what the speed is and all of these other values, and then finally it checks what the stance is to be able to enter this post search database here. So all of these should be any, and the stance for stand idle should be stand. And then we're going to find our stand idle stance, and we're going to duplicate it. And I'm going to choose rifle for this new one. So rifle stand idle. I click it and accept it. And then we'll get one of these stand idles and we'll just duplicate it. Choose the new rifle idle. And where it says stance here, drop that down to rifle. Okay. And as you can see, for my katana ones, I've got it on katana. For my magic one, got it on magic, and for spear and pistol, same. Okay. So now we're going to click on this and open up the PSD dense stand rifle animation, and you should only have two in here. You should have the stand idle and the crouch to stand. If we just disable this stand idle for a second, we're going to go to our content. I've got my rifle animations. Just need to find the idle one. This rifle idle break fidget. I'm going to retarget it. So it's on the UEFN. I'm going to do rifle idle break fidget, and double check that that is fine. In fact, I'm going to do this MF one instead, so that one looks better. And we're going to export that to our animations. This is in rifle. Just going to make a new one and export that. Now I'm going to open that up and I'm going to tick looping and enable root motion and force root lock. And I'm going to shove that into there. So now, when I move through my stances, so what did I put it on? So we're in spear, twin sword, magic, pistol, rifle. As you can see, here we've got our idle rifle animation. It's perfectly fine. And if I had a rifle, it would look quite good. So those are that's our idle setup. Okay. And now if we go to our runs, we can add our enum or value again and bind that to our stance. So now we want, if we have a katana on here, and then the rest to be any, the second one down to be stand, So if we duplicate the loops PSD, so we find it and duplicate that, and I'm going to call that stand run loop magic. And then we're going to come to the PSD and duplicate that. And we've got loop magic. I'm just going to make sure that this enum is on not stand, but magic. Like so. And then we're going to open that up. I'm going to go to my magic animations, find our run ones, just make a new folder for our run ones, folder for UEFN run as well. And then come here, retarget them to the UEFN. And got our run, and it needs to be the root motion one. So root motion like this. I'm going to export that. I'm going to put that into our mage pack. So, and then I'm just going to asset actions, edit selection, make sure root motion is turned on, make sure loops turned on, make sure force root locks turned on as well, and then close that. So now I'm just going to go through these one by one. I've got the mage run back root motion, so I'm going to click on this little eye and disable it. So I'm going to find my retargeted animations. I'm going to get them all and just drag them into here. And then I'm going to find the equivalent one. So this is run B, this is run back left. Don't know if we've got back to left. Yeah, back left. This is run back right. This is forward. This is forward left. And forward right. And LL is left and LR is right. So like that. And then the rest are fine. You can see that it's moving into the backward state, but it's not moving into our forward state. And it's moving into our backward state a lot later than what we would want to. So we're going to open up our forward run, and we're going to right click, add notify state, and we're going to override the base cost bias. I'm just going to put that in there, and then hopefully there we go. It's going to transition into that. And then when we go backwards is already working a little bit. And we just need to change that to be on the left as well. And then the other thing to do is inside the animations. So we're going to grab we're going to untick this looking and just open this run loop right left. And we're going to grab this enable orientation part, and then inside each of these nodes, so inside each of the new ones, so back left, we're going to open that up, and we're going to paste that inside here, and inside back, we're going to do the same. Inside back right, we're going to do the same. Inside forward, we're going to do the same. There we go, there's our magic stance working. So then we've got our sprint as well that works, and it goes straight back into our magic stance, like so. So now I'm going to do my utmost to explain what's going on and how it works in a bit more detail to give you guys the ability to sort of do it yourselves. And then in another episode, I'll be doing a more in-depth sort of advanced tutorial that includes all the starts and the stops, and hopefully we should get a decent system going as well. So this chooser table is the bit that runs the whole thing. It chooses from all of these other choosers, so everything's a nested chooser, and it outputs this post search database. So that's the bit that ends right at the end. So even if we go through stand idle, we've got all these PSDs, and that's the bit that outputs all the stuff. And I'll talk a little bit about how that works, but I just want to stick on choosers for a sec. So the chooser is looking for anything that matches the best criteria. So we've got movement mode on ground, the stance. I've got mine set to not crouch, because if it's not crouching, it's doing one of these and it's stood. But you can set yours to an enum value. You can add in the enum or value here and do stand, crouch, pose, whatever, but not crouch for me works fine. And then I've got crouch is crouch, and at some point I'll have prone is prone as well. Then we've got the movement state, so is it idle or are they moving? This is all calculated inside the ABP, which we'll take a look at in a sec. And then we've got the gait, which is just how someone walks. So if I go into the idle, and again, I'm no expert, so take everything I say at face value. I'm just trying to give you a starting point. Hopefully someone sees this and either improves on it or does something else, and we can like come together as a community and actually make sense of it. So then we've got all these PSDs, and all our idle ones are the same. So just landed light, just landed heavy. So this is calculated, should turn in place false. And then for us, it changes the stance. But for everything else, it just works on anything. On the speed 2D value, that's how fast someone's going. Just landed light, just landed heavy, should turn in place is pretty explanatory. And then you can come here and add all sorts of other values. Now currently the input of this is the ABP sandbox character. So any values that are in the sandbox character are able to be chosen from here and work in that way. You can check out my other chooser video to see more how this works. So now if we go into our animation graph, we can see that we're not using any layered blend. It's all done in the actual motion matching system, and it's evaluating the dense chooser here. We can see the input here is self, which is the animation graph. You can see that it outputs a list of databases to search, and then from there it gets the motion matching and gets the database, tells it that it's code set to database, and then plays the animation via the post trajectory node. As I say, everything is made by trajectory, and if we come into the event graph, we can see that these are the variables that are being driven. Some of these we're not looking at. Logic one here updates the trajectory, which gets where we're going, and then passes the trajectory in. So it post searches, it generates the trajectory, it handles the trajectory for wheel collision, and then tries to calculate past trajectory, past velocity, current velocity, future velocity. From there, it gets the transform, it gets the root transform, and then we get our velocity from here, which is the bit that we're checking inside here, because it's passing into a speed 2D. So then we're checking the speed 2D inside the database for our stand idles to see what PSD to choose and use. From there, it updates the states, which is the bit that we added on to the bottom to get our stance. And it's calculating whether it's walking, running, sprinting, or moving, or idle, and what its orientation is as well. So all of this stuff is getting passed through to our database to be able to be chosen. And then it gets the direction and chooses which sort of direction to move in. And then same for rotation on there, so whether it's orientated or not. So the chooser looks through all of these things and then finds the closest one. And because the main thing that we're changing here is our stance, when we change our weapon, it'll always choose sort of the correct one for it. So right now it'll find katana idle, and it'll find the most appropriate thing for that. So if we're not in a transition from a crouch to a stand, then it'll play the idle root motion animation. And the way this works is that it is based on the post search schema, which is this, and this is based on the trajectory of these channels. You see the position, velocity, and the pose channel. I'm not going to go into detail on this, mainly because I don't understand it hugely, but it runs on what is called K nearest neighbor. So that's KNN or K decision tree, and both of those are machine learning algorithms. And the way that K nearest neighbor works is that it takes a decision point, so here, and then looks for all the other decision points that are around and picks the closest one or the best one to what it needs. So this one, and then it will do this one, and then it will run it again to see, oh, what's the next one that we need to go to. We'll go to this one, and then it'll reassess based on its neighbours. That's a really rudimentary way of looking it up, but that's how K nearest neighbour works in essence. And so this one is looking at a sample of 200, and the way that K decision tree works, a bit like a family tree, and each decision point and each end results in an animation that gets chosen. But again, super rudimentary. Don't quote me on that it's working exactly like that. In terms of our walks and runs, so if we go to our katana one, because that's the one that I'm most confident in, if I look at the animation itself, so we can see here that it has, the one that I've got has a frame rate of 60 FPS, and you can see that the number of sample keys are 154. That's what each of these little dots are. So there's 154 of these. And if I look at one of the other ones, so if I just take off loop B, so by default, the ones that come by default are 30 FPS and therefore samples 78. So there's a lot less samples in here. So you can get away with 30 FPS or 60 FPS. In a later tutorial, I'll show you how to change this and create your own animations to be used in here, which will be fun. Run back that I use here, so I'm only using 8 animations as normal, and you can see here that this enable orientation warping, that reads a curve inside the anim graph and says that actually, yeah, this animation that's being chosen gets more priority because it has enable orientation warping. So as opposed to moving back left or back right or forward, this one gets chosen to say, yeah, it's strafing. In the others, there are other keys that you can add as well. So this one has foot speed, this one has foot speed, there's also move data, phase and enable play rate, and this is just monitoring at what point. So this one's for the left foot, so that left foot is at 0 here, you can see because it's at the bottom of the curve, and then it starts to move to get in line, move in, and then again at 0 it hits the floor just here. So you can fiddle with those and set them up. They're a little bit finicky, and again in an advanced tutorial I'll go through them and see what we can do. So currently we're only adding 8 animations to this, the standard blend space type animations, and we're blending in and out of them. So if we look at this run loop forward, you can see that I'm modifying the cost, and this modify here is adding bias to choose this for when it goes forward. But there are also other options here that you can do some research on. Block transition, exclude from database is pretty self-explanatory, and override continuing cost, sampling attribute and sampling event. So all of these I'll put a link to so you can do some research on yourself, but the one that sort of overrides everything and says, yeah, choose this, is just this one here. And that gets us to be able to do cool runs like this. It sets up our whole system for us to work that way. And even though we are missing plenty of animations, so if I look at this post search database, I've turned off plenty and I'm just using the ones that are here. That's why it looks a little bit weird sometimes. So if I go from this into sprint, then you can see the transition isn't the same. Or if I jump, then I'm still using the old jump and still using the old hand wave at the bottom. It's not gripping a sword or anything, because it's moving from one animation state here to the other one. And then if there isn't an animation state, the sparse database, which is this one, kicks in and handles any extra stuff as well. So these stand idles. So the sparse one will kick in and grab the loop that we need. So if I check this sparse one, this one has far less animations in, and they're still the frame quality that we need, and they are the same animations, but it just ensures that we're captured, so there's no loss of data. So we'll do a video on adding the pistol animations, because we've got Lyra has more pistol animations that we can steal. So here I've already retargeted them. We've got our jog, so this one's got a pivot, and we've got stops and starts, and so we'll add those as well and see if we can get something a little bit smoother, a little bit nicer going. But for a basic implementation, just using 8 animations as you would do a blend space, this is how you would do it. Thank you very much.